So I'm trying to prove that these two triangles are similar. I've got the sides matched up together, and I have no angle markings or angle values. So that means my only option for proving that these two triangles are similar is going to be side, side, side. So we're going to make a flow chart using side, side, side similarity. So let me explain to you how you're going to write this in your flow chart. Let's start with the smallest side in the two triangles. So I've got side BC in the first triangle, and that matches up with DE in the other triangle. So I'm going to write BC over DE because I always want to put my corresponding sides or my matching sides together in one fraction. And now I'm going to write the length of BC, which my diagram tells me is 4.5, and the length of DE is also 4.5. And then I'm going to reduce that and tell me what I get. So 4.5 divided by 4.5, that is just 1. So that means that my scale factor or my zoom factor for these two triangles is 1. That is the common ratio. And if all three pairs of sides have the same common ratio, these two triangles are going to be similar. So let's move on to the next pair of sides. We'll do the next biggest length, which is 6. So that's AB in my first triangle. And that is going to correspond with DF in my second triangle. I've already highlighted them with the same color to show that they match up together. Now I'm going to write the actual length, which is 6. So I'm going to write 6 over 6. And then 6 over 6 reduces down to 1. So awesome, they have the same common ratio. We are on our way. If this third pair of sides has a common ratio of 1, then I know for sure that these two triangles are similar. So my third side is AC, and that matches up or corresponds with EF. So I put those together, AC over EF. Now I'm going to write the actual length, which is 7.5. And 7.5, and yep, it has the same zoom factor of 1. So I have just met the side, side, side similarity condition. So I can draw arrows from these 3 fact bubbles, and I call them fact bubbles because I got them from the facts that are in the diagram. And that is going to lead me to my similarity statement. So remember, when we're writing a similarity statement, I get to choose the order of the first triangle. So I'm going to write it as ABC. You can choose the letters in any order for the first triangle, but the way that you write that first triangle is going to dictate how you have to write the second triangle. So first triangle ABC is similar to. Now I need to write these so that it tells me which angles are congruent to each other. So angle A is between the side length of 6 and 7.5 that I have highlighted green and blue. So it has to match up with angle F, which is also between 6 and 7.5. So since A was written first, F has to be written first. B was written second. That's between my side length of 6 and 4.5. So it has to match up with D, which is between 6 and 4.5. Because remember, the similarity statements tells you which angles correspond with each other and are congruent to each other. And then finally, C will correspond with E. So that is going to be the last letter that I write. And now I need to write the reason that I could say that these two triangles are similar, the shortcut or the similarity condition that we got, and that is the side, side, side. Those are my 3 fact bubbles. I have 1 pair of sides, a second pair of sides, and a third pair of sides. So I've got side, side, side similarity. Now I notice that the zoom factor of these is 1. That means that they are the exact same size as well as just the same shape. So I can see in the chat, someone asked me, what's the difference between similarity and congruence? Well, that's what we're getting to right now. So these two triangles are similar by side, side, side similarity. And so I use my symbol for similarity, which is this little tilde right here. It is a kind of a squiggle symbol. But I also notice that for these 3 sides, the zoom factor is 1. That means that they are the same shape and the same size. So that is what we mean by congruence. So here is our symbol for congruence, and you guys should write this down in your notes, these two symbols. And the cool thing about this is it tells us that they are equal, so they are the same size. The side lengths are all equal to each other, and they are similar, which means they are the same shape. So that's what it means for two shapes to be congruent. It means that they are similar, they have the same shape, and they have equal side lengths. They're the same size. So that's the biggest difference between similarity and congruence. Any two shapes that are congruent are similar, but they also have a zoom factor of 1. They are the same size. And that's where we get that symbol for congruence. It kind of merges the two symbols for equal and similar together.